All right, good. How's everybody doing? Great. All right. I have a lot that I want to go through today, and I hope you guys find it interesting and exciting. It covers matrix math, some applications of matrix math, and then we'll introduce functions. How many of you have seen functions perhaps in a different class? A handful. Okay, so this will be pretty new stuff. Functions in and of themselves may seem simple and almost pointless until you really start to understand two concepts, which we'll get into in a bit, which deal with sort of variable scope is a term that's used around, and abstraction. So we'll talk about that as we introduce functions. Cool stuff. The plan for, I do not think we will get to recursion today. Recursion is another cool concept. It's another way of iterating over, like for loops and while loops are a way of iterating. Recursion is another way. It's very crafty, very clever, but you can't actually talk about recursion until you master functions. So we probably won't get to that, but maybe we'll just introduce it really briefly today, and then really talk about recursion next week, and do some of the sections on simulation that are for next week. The week after that is exam 3. Okay, so just kind of give you where we are in the semester, and there's not much left in the semester. I'll talk about that last part.
I don't want to jump ahead here, but exam 4, is that just the placeholder for the final exam?
Yeah.
Okay.
Call it final exam. Final exam seems more scary.
All right.
This is it. This is the final. Same night. Same, yeah, that's 16th, I think, in fact. Yeah, sorry. Same night, same room, same bat channel. Question back there?
No.
Oh,
I didn't move my hand.
oh, I thought somebody had a hand up there. So the big question is what? Oh, sorry. Go ahead.
People were talking about at the final. So is that the 16th during finals week? Or is that? Oh,
I
okay.
believe it is.
I can sometimes like the night class. It's like you get it the week before finals week or the week of finals week. Oh, this is the Thursday section at night. So yeah, it'll be.
It's if that is
during finals week.
yeah, if that is not finals week, then I have the wrong date.
Exactly.
And the exam will be on finals week.
Exactly.
But I'm pretty sure that's the right date. I'll double check. And I think there may be some oddity where we're getting lucky here because finals week is starting on a Thursday. Getting lucky meaning like we're not the last final, we're actually the earliest final. It does start on Thursday?
Yeah, that's the first day of finals.
So that's why it's the 16th as opposed to
Well, because like I thought like so my last semester when I had this time slot, we actually, even though it was finals week, it was different for night classes. And so I had that session, which was technically finals week, but I had it as a class, like with a lecture and everything. And then I had to wait a week to finish my last final.
Let's check the schedule. Yeah. Cool. Somebody remind me later on. We'll do that. Yeah. Yeah.
Is it accurate to describe our class as having just at the end of the class having gone through the entire textbook? Like every
No,
not accurate.
in fact, we've already skipped some. There's some stuff later on in that.
For sure. Just because it's not useful in real life, or just because we're out of time, or it's too hard.
I would not say that it's not useful in real life. I would say that some of the stuff that's later on in the book probably is quite useful in real life. Whatever real life is. Is it too hard? Some of the stuff maybe too, like some of the stuff sort of assumes you have a certain foundational knowledge either in the maths or the sciences or the engineering subjects to really sort of like make it all click. And I'd say the other part is just time. I mean, you know, this kind of gets back to the discussion we had a few weeks ago when everyone was a little upset. Like this same course using the same book elsewhere, maybe barreling through it at a much faster pace than we are, right? So if you do expect to cover the whole book, we'd have to go faster than that. Good point. We cool with that? Okay, so this last quarter, where do I want to head? I definitely want to introduce everyone to the concept of object-oriented programming and how it differs from what we're doing here, which is functional programming. I don't think we'll do exercises in it because it's a real shift in sort of how you think about it. I might change my mind about that, but that's kind of my perspective at the moment. I definitely want to get you all exposed a little bit to some software development stuff, which is really just like frameworks for software development, revision control type stuff, just so you know that this exists, right? And then you can, when somebody mentions it to you in the future, you can be like, oh yeah, I think I've seen that before, go look it up. a topic that is on our course outcomes list or course topics list is computer architecture. So I want to just give you a real brief intro into what computer architecture looks like. How do the bits move around on that thing when you have a command that says add X and X? Right? None of these topics, okay, numerical methods does have to do with MATLAB, but the other ones really aren't MATLAB topics, right? They're computational methods topics or software system topics. So as a result, once we get to numerical methods, what I might do is think of like a really meaty big project that is our MATLAB project. I don't know, how do you guys feel about me making it more open-ended, like for it to be something that you think is cool? Is that too open-ended? How about a menu of options? Like here's 4 ideas.
More ideas and open-ended. That's what I would say. Or if you didn't want to do one of the ideas, you could do it.
Okay, so your own idea is an idea, or pick one of these 4. Okay. And what that might end up being is something that takes us through the rest of the session. Like it's this big project with a lot of points that takes a significant amount of effort. Meaning, if you wait the last minute to do it, it's not going to look pretty. Okay, cool. I'll think about that. Yeah. Everyone okay with where we're headed? Yeah, I have no choice. 2/3 into the course, what are you going to do? All right, great. So like I said, we have a lot to talk about today. Matrices, matrix math, and functions. And so let me turn the projector off. Why are these things? Oh, they are probably intentional. So if you recall from 2 weeks ago, we said that you can kind of think about matrices or address how matrices might work in 2 different ways. Does anybody remember the 2 different ways we talked about?
One was like a special matrix math.
Yeah, exactly. So one, we'll call that number 2. It's
And then the other was tabular data.
exactly. What is a presentation of tabular data you're all familiar with? You've seen it before. So Excel, right? Good. That's what we talked about last week. So today we're going to talk about matrix land and matrix math. This gets a little into linear algebra. How many are you in linear algebra? Okay, cool. So some of the stuff that you're going to see now should seem like old hat. Some of the stuff you'll see now will be kind of like, wow, I wish I knew how to do that 6 weeks ago because then I could check all my answers. So, yeah. Okay, so given 2 matrices, and you want to multiply them together. Everything we've seen so far is this element by element multiplication, right? Where I say, I take this spot and this spot, and I multiply them together, and the result goes into exactly the same spot. Yeah? We just do that element by element. That's been our element by element operations. How do we make sure we get that in MATLAB? Period. Exactly. So, if you had a chance to read Gilbert's Triangle, you know that really a lot of this comes from figuring out a really cool way to solve simultaneous linear equations, right? How can you represent your linear equations as matrices? How do you then go about coming up through the Gaussian elimination process? How do you represent that via vectors to get to your final result? Vectors and matrices to get to your final result. So this thing that is sort of seems like crazy matrix math has its birth there. And I don't really want to rehash that. It's not the core part of this class. But again, I say, if you haven't had a chance, go read Gilbert's Triangle. It's a really cool presentation of how do we get from there. So let's label this guy A, this guy B, and this guy C, right? And so C is the result of this matrix multiplication. Given any spot on C, we're at indexes I and J. What's I refer to? Row. And J? Great. to calculate the value for the element at row I, column J, in C, you are basically going to compute the scalar product of the I row, the ith row of A and the jth column of B. That's the high-level definition of matrix. The resultant matrix, every single element in here has to be computed one at a time. The value at this location, I, comma j, row I, column j, is the scalar product of the ith row of the first matrix and the jth column of the second matrix. Does anybody see something here, like a hint of a restriction that comes out of that definition? Meaning something about rows and columns. Yes. So what this gets to is a super, super important thing, and I want to use some other colors. That. In matrix math, the dimensionality must be correct. It is key. So using capital letters to denote these matrices, and I'm going to write this more backwards than you might be used to because we're going to say this is MATLAB land, okay? Given a MATLAB command like this, matrix C is going to equal A times B. Then the requirement is that the number of columns in the first matrix, here's matrix A, must match the number of rows in the second matrix, which is B. You okay with that? So what this suggests is, if I have a matrix like so, that is 4 by 2, whatever I multiply it by must effectively look something like that. It could actually look like what? It could look like this. It could actually even look like this. Okay? Because there's this row content out of A, column content out of B, that requires that the number of columns you have in that first matrix matches the number of rows in the second matrix. All right, so now you know that constraint. So what does this math actually look like? What does it really look like? Actually, wait, before we get there, let's define the dimensions of the result. Okay? Do that over here. So, given an A who is n by m, and a B who is m by p, notice here that m repeats. This is sort of the matrix notation for the same statement up here. Your result will be, you want to give me a guess? N by p. Exactly. N by p. So, we put that up here. N by m by p And you okay with that so far? Okay, so what does scalar product look like in our case? This first element is the scalar product of this first row and this first column, the jth column. Okay? So it's this multiplied by this plus this multiplied by this. And that's the result. Might actually help for us to let's do this a little bit differently. Let me put some indexes in here. Everyone okay with this indexing that's here?
Yep.
The first index is the row. The second index is the column. Okay, so C11 actually ends up being A11 times B11 plus A12 times B1. Sorry, 2. You guys want to help me out with C21? So C at row 2, column 1, what's going to equal?
C21.
Say again?
A21.
A21
Times B1.
plus
A22 times B2.
and this just goes up. So that's what the scalar product looks like. It's not too bad in the smaller matrices. You get into bigger matrices, it gets pretty nasty. Okay? So if you are here with a matrix A like so and a matrix B like so, you give MATLAB that multiply, the result you will get is numerically going to be this matrix C. That's the matrix multiply. That's the default behavior of MATLAB. I'm going to pause there for a moment and see if you have any questions.
Why?
Read Strang.
Huh?
Read Strang.
Reframe?
Read Strang. Gilbert Strang. The PDF that I posted online.
What was it? 121 to 124. Yeah.
That's a doc.
Sometimes people call it that.
Asked my linear algebra teacher, why did I do this way? I don't know.
Really?
Yeah.
Okay. The reason it's done this way. Okay, so you know Gaussian elimination, right?
Yeah.
The point of Gaussian elimination is to get. Let's just. Can we come back to that question?
Yeah,
just
I
a
want to
moment?
get to it.
Okay. No, I do feel like it's important to at least give that one a little conversation, but we'll get to it really soon. Okay, we'll do it real soon. Yeah. Okay. Any other questions? So let me ask you all this question, right? I have a question now for you guys. Now that you know how this works, this definition for matrix map, the question is, Are those two equivalent?
No.
No. In almost all cases, matrix math is not, what's the principle that when you're allowed to move stuff around? It's not commutative, right? So order matters. Order is super, super important. Okay, so let's go ahead and try to entertain your question real quick. So let's start with the simpler case to try to sort of say how this, why does the multiply work out like this? Okay? And of course, I think Strang does a better job than I can of explaining this, but I'm going to do that. If you are given a set of simultaneous linear equations, okay, 3 variables, 3 unknowns, it looks something like this. Okay, let's say we have something like that. If you, for a moment, think about how could I represent this thing as matrices? Okay. We could effectively have a 3x3 matrix that represents all the coefficients that are here. Okay? Let's call that A. Okay? Then we can effectively have a matrix that represents all of our unknowns. We could call that X. Okay? What's that? Yeah. I mean, we could call it X, Y, Z, but for simplicity, we're just going to call it X. And then we have these numbers that represent the values that sum out of each equation. And we're going to represent that as G. So if you continue with this matrix representation, I can sit here and represent X as a column vector. And these are unknowns. So even though I called it X here, because that's just the convention, this actually represents the variable X up there, the variable Y up there, and the variable Z up there. And actually, just to eliminate that confusion, let's change that to W. Okay? So I've called this X, but X actually represents the 3 unknowns. This is the W, this is the Y, this is the Z. B on this side is intended to be 10, 5, and 1. Okay? Now, put all the coefficients in. Okay? Is that? Thank you. Put all the coefficients in. 3, 2, -1, -1, 3, 2, 1, -1, -1. Okay? And I'm Gauss, who's a genius, right? According to Strang, if you read Strang. And like, hey, I can represent this way. What would be the math that makes it true? What would be the matrix operation that makes this true? It is that to make, like, the rules that make this statement true are the rules of the matrix math we saw here. What do I mean by that? Let's work it out, right? This is C at 1, 1, right? It is first row, first element, multiplied by first row, first element, plus first row, second element, multiplied by first row, I'm sorry, second row, first element, etc. Right? That scalar product of taking this row times this column gives me, it reconstructs my original equation. 3W plus 2Y minus 1Z. That's exactly my original equation. This was 10, right? So sort of working backwards, I can expressing it this way, defining my matrix math as that, I can recreate my original simultaneously.
Is that supposed to be 2y, 2z?
Sorry, these are question marks. Let me take them away. And it gets really, in go to string, it gets cooler, right? Like, what is your first step of Gaussian elimination here? What's that? You want to eliminate, yeah. So which one should what should we eliminate first, guys?
Negative W.
Yeah. How do I get rid of this negative W? All right, you guys are going too fast for me. So what am I doing?
Gaussian elimination.
Right. So I want to get rid of that negative W into the second equation, right?
Yeah.
Okay. So what I'm going to do is create a really cool matrix called my elimination matrix. Okay? The elimination matrix looks like this. Okay? And what do you tell me? What do I want to multiply this by?
Let's go with 1/3 of the first equation.
Okay, so 1/3 times this plus that, right?
The other way. Top equation times 1/3 and that's wrong.
Let's do it the other way around. Can I get it 3 times this instead?
Fine.
Yeah, is that okay? All right, I put a 3 here. Okay. If I do the matrix math for this, guess what I get? I'll start to slowly, this will help me work towards my solution. I'll start eliminating this, and I'll end up getting, we have to do the math, but you end up starting to get this thing called the upper triangle and the lower triangle, where your lower triangle effectively represents these operations that you need to do. The upper triangle gets you really close to your solution. And that's what MATLAB does internally when we solve for linear equations in a moment. And you probably have had, if you've taken linear algebra, you're probably doing this by hand. Is that right? Yeah. Unfortunately, right? You guys call this what, the low LU? Is that right?
You can do it both ways, upper or lower triangle.
Okay. So your linear algebra professor is like, I don't know why we do
Oh,
this one.
dude.
Okay.
60% of my class failed the last test.
I know. I mean, I think this is why, like, if you're, especially if you're taking linear algebra right now, read Strang. It's such a nice presentation of it. It's intense, but like he tries to say, like, this is why we got here. This is how we got here. This is why we do the operations this way. And wow, look, these are the applications to it. Wait, that comes later.
And his respects.
Yeah. Give it up to Gauss.
Pour it all out.
All right, so we got a little sidetrack, but that's okay. Is that the right time? By an hour, right?
Mm-hmm.
But so you see how this is, and this is only the beginning of how matrix math is kind of cool, right? I think it kind of has its germination here, but then all sorts of other cool stuff can fall out of it. Yeah. Okay. So we jumped ahead to the linear equation part. So let's talk about, let's just wrap up the linear equation stuff because we're already there. And then we'll go back to some of the other applications of the matrix math that are introduced in the book. Does that sound good?
Yep.
Okay. Oh, one thing I will say. So how many of you have the 6th edition of the book versus, like, how many of you have the 6th edition? Handful. And how many of you have like 4th or 5th? Okay, so his presentation of this changes between these editions, which is really annoying. So what I might do, what's that?
I think most of us have what was recommended by CCSM bookstore.
Which is my fault. Yeah, whatever they recommended was whatever I picked. So I was unaware of this change in representation like change in presentation of the matrix, right? So what I'll do is I'll try to scan the sections from the 6th edition that have some of the stuff we're talking about here, so you guys all have access. Okay?
We won't tell anybody you did
I know. Thank you.
that.
I appreciate that.
Probably should have said that on camera.
I know. Yeah.
And
We printed it out after.
Okay.
I'm not including myself.
So we saw a snippet of this early on in the semester where we used we use MATLAB to help us solve some stuff. Yeah? All right, so let's just stick with the same equation we have here, okay? And we're going to use A, B, and X, right? Typically, we're going to use capital letters for matrices. We'll continue using lowercase letters for vectors, okay? That helps keep things a little bit straight here. Doesn't always straight. So A is going to be our matrix that represents these coefficients we have. So, you guys remember, I can create a matrix by using square brackets, space or commas to delineate rows. What do columns? How do I delineate rows? Semicolon. Perfect. Okay. Those are my right coefficients. Those look correct?
Yeah.
Yeah? Okay, good. Then I need to declare my B. The B is the numerical values on the right-hand side here. That is a column. So I have a lot of ways I can make a column. I can start with a row and then transpose it. You guys remember that? Oops. And that gives me my column vector. Everybody okay with that?
Yeah.
Okay, now this is the really cool thing about MATLAB is you can, using A and B, and this funky notation called sort of, it's like backwards division, is sometimes is a term that is used. You go A / B. This basically says solve this system of linear equations. Sometimes people call it B over A under B. The book talks about a bunch of ways to represent it. But if we do that, we effectively get the solution, which is X. And those are the values that come out of MATLAB for solving the system of simultaneous equations.
So is that multiplying?
No, this is actually not the matrix math. This is many operations of matrix math, developing that elimination vector stage by stage. So you get to the elimination matrices till you get to the LU matrix to eventually get you to a solution that you can put back into the equation to get the results. So that represents your W, Y, and Z, and you can plug them in here and see if you get the right results. In fact, we will do that here to prove to ourselves that this was the right solution.
So that's perfectly analogous right there to your X column vector?
Yes.
Okay, great.
Yeah. That ants is my X. In fact, I should have executed the command like this instead. You okay with that? All right. So there are two concepts that become important when using computers to solve your linear equations. You may have seen these two in that earlier exercise that caused a lot of heartache for everybody. One is knowing the residual. Okay? The residual is how far off is this answer from the correct answer. Okay? So assuming these are our x's, can somebody help me think of what the math should look like to get back to my solution? Like, basically, if I tell you this is my x here, right? And I want to actually get this 10, 5, and 1 back, how might I do that? What would the math look like? Yeah, I can just go a times x, right? Right? X is a column vector. It represents the values that are here. If matrix math holds out, I go A, which has all my coefficients, times X, which is now my real values, I should get B, right? So let's try it. Dot multiply or regular multiply?
Regular.
Regular. And what do I get? So this is one way of validating, hey MATLAB, what was this thing? What did you really do? It got me the solutions to X. And then I did the math back out. This is like taking my answers, plugging them back into my equations and checking the results. And you can do it by hand and verify it yourself too. Right? So there are times where your solution ends up being nowhere near correct because of various other issues. And so you can calculate the residual. The formula for that is effectively this, and then compare with the b that you're supposed to have, right? So effectively, take your solution, your x, multiply it by your coefficients, and then subtract the answer you're expecting. And so ideally, yeah, in a perfect world, if everything worked out, your residuals are 0. Residuals are not 0, then you've got a problem. Oh. Oh, geez, how's that possible?
You got a problem. Yeah, your magnitude.
Ah, there you go. Good eye, Cody. What's the magnitude here? This is damn near 0. This is potentially computer error problem, like rounding error on the computer side, but at -14. Okay, that's a residual of 0 as far as I'm concerned. Right?
How's that even possible?
It's just a small number.
I mean, no, regardless, if we were to do this with integers, it would
You'd probably get it right. Yeah, so this is probably a computer rounding.
Okay.
Yep. Is that crazy?
Yeah.
All right, so let's look at a situation where the residual comes out wrong. Typically what happens in this kind of situation is you have more equations than you have unknowns. And so there's effectively, you could think of it as like contradictory statements. And so let's see what that looks like equation-wise. Can I erase this stuff up here?
Yeah.
Which shows up best on that camera, the blue or the, where's the black? The black shows up better. So let's say we have a situation that looks like this. X minus y equals 0, y equals 2, x equals 1. Right? You can already see a problem, right? I mean, just sort of like quickly looking at it, you can kind of see a problem. So what does our A matrix look like for this?
1, -1, 1.
1, -1, 1,
0,
0, 1,
1, 0.
1, 0. Great. Our x is going to end up being how big? 2 rows, one column, right? And what does our b look like?
0, 2, 1.
Yeah. If you think about the rules again of your matrix multiplication, this all looks consistent. It looks kind of weird up here, but it's consistent. So if you're not careful, and you just go willy-nilly with MATLAB solving your linear equations for you, you might get yourself into some trouble, right? So MATLAB back up here, let's do a little clear. Oops, there we go, clear. Let's see. All right, so let's get A in here. What do we got in A again? 1, -1, 0, oops, 0, 1, and 1, 0. Right? And B equals, oops, that was not right. 0, 2, 1. And how do I get it to turn from row to column? Transpose. All right, good. Okay, and now what's my math look like, or my MATLAB command look like? X equals A\B. Hey, MATLAB's like, here's your 2 answers. There you go. No warnings, no errors, no nothing. So this is encouraging caution. Anytime you use a calculator or a program to computationally arrive at an answer, you've got to know how that thing is functioning to get you to that answer, because then it can easily mislead you. Just because you got an answer does not mean it's right, doesn't mean it's a good answer. It does not mean that you should have confidence. Right? This is the same issue with significant digits, right? You guys, hopefully by now you know if you take a funky number divided by another funky number and you end up with like 9 decimal places from your calculator, you know that those 9 digits don't necessarily mean anything, especially on the experimental side. Right? This is a similar sort of idea in MATLAB. All right, so how do I calculate my residuals? Yeah. Can I do x times a? Remember the matrix math is multiplies not commutative, right? So gotta go a times, oops, sorry. Gotta go a times x. And minus b. And that is a much larger residual value than we had before. So what MATLAB tries to do, oh yeah.
I'm still kind of confused how a times x is kind of like the reverse. Like to find what these should be.
Okay, good. Let's do it real quick, okay? All right, so I know this is called x, the column vector x, but for a moment I'm just going to plug in my x and my y. Okay. If I do this math out, the matrix multiply out, what do I get? Right. For the first dot product or the first scalar product, what do I get? 1 times x, right? That's x. Negative 1 times x. I'm sorry, negative 1 times y, so minus y equals some value, right? Okay. What do I get on the next one? 0 times x, so there's no x. 1 times y, so I got y equals some value. Right?
Oh, okay, I see now.
Third one, 1 times x, so I got x. 0 times y, so there's no y equals some value. Right?
So it just gets back to the original equations. Okay.
Yeah, it's taking the numbers I have here and reconstructing these equations. And then the last step is, well, I know that this was my original results here. Subtracting that out and saying, hey, what's the difference? What's the difference between the solution and what I said it should be?
So if the rows and columns don't match, will it still try to do a calculation, or will it tell you?
If the matrix sizes are not correctly sized, it will error out because it doesn't know how.
How does it still get an answer then?
Great question and great answer. So it's doing this least squares fit. It's doing a best fit. I don't know if you've ever been in Excel. You're like, hey, make a nice squiggly line for me that fits all the data points. This is kind of doing that. Like,
Which was intended, it was written in the program.
Yeah.
So that's useful for
It
some
can-
purposes.
yeah,
Okay.
those are the values for x and y that come closest to solving this. But they're not perfect. Like, and the residual, like if you do the line or whatever for the solution, the residual is actually the distance between, I think, the point and the real point. Like the point on the line and the real data. So this will be considered what's called an overdetermined system. Okay. There is a homework where I ask you to check the residual and figure out is the system overdetermined or not. Right. So not only do you need to do the residual math, but you need to then do some conditional around the residual math to say, hey, is this overconditioned or not? I'm sorry, overdetermined or not. Okay. Let's do one more thing.
And what tells you if it's overdetermined or not?
The residual, if it's not close to 0. And like in that last case, we didn't have exactly 0, but we got 10 to the negative 15, close to 0.
But the other two numbers are up there for like point something.
No, they were all. So remember when MATLAB presents to you either the data in a vector or the data in a matrix, the multiplier, the scaling factor, applies to every element. Right? So I think what you're talking about is, I don't have it here. This one, right? Count, right? Oops. That's my x.
Oh, that
This scaling factor applies to every single value that's presented to you. In fact, MATLAB does this on purpose. It chooses one scaling factor and it applies it to that whole data set rather than spitting out over and over again. The same applies to that big matrix. And I think there was a discussion forum post about this too, where we had this huge data set, and that was like well gone. And everyone was like, why does the scale not match? Why does it not match? If you turn more on, you can get it to stop.
Noticed recently you've, for solving for x backwards, you've done a \b. Can we do b slash or a or is it b slash a and get the same results? Or
No.
ditching that in here?
The order, the commutative, this is effectively the commutative aspect of it.
Oh, I see.
Right? A is intended to be your coefficients, and the B is the right-hand side.
So that doesn't mean division sign. That just means.
Well, sometimes people call it left division.
But it's not B divided by A.
It's not B divided by A. Yeah, good point.
I was wondering because normally if you put a division sign, you got to put that period in there so it doesn't do it.
Right. In MATLAB land, this and this are not related. Might be the best way to think about it. For now, think about that. Do we want a break? All right, let's take a 10-minute break.
That's nice.
Why is this going?